Hello everyone, welcome to Top Scholars, the Smart Learning app. In today's lesson, we are going to understand some of the basics of calculations. So, we will not solve any particular concept, but we will see how to improve our calculations. So, let's get started. Firstly, in terms of the introduction, what do we need to remember? So, what needs to be remembered? Firstly, it is the tables up to 30 yaad hona chahiye. Next is squares up to 25 should be on the tip of your tongue. And cubes up to 10. However, if you do till 15 also, there is no harm in it, but definitely cubes till 10 needs to be by hearted. Tables up to 30, but then there is another trick also. If you want to know tables above 30 till 100, how do we solve? Okay, so we'll see later on. Now, doing tables up to 30 by heart is the first thing that you should be doing. Okay, next, let us understand how do we find the squares. We know that we have to remember tables till 30, cubes till 10 and squares up till 25. Now, given that we have to remember squares up till 25, but what if there is some bigger number? Remembering by heart is not a piece of cake. So, what do? We use the help of tricks. Now, for that, let us see how do we find the squares. Square of any number between 25 to 50. Now, the first thing is I have broken down the numbers. So, first to 25 you are by hearting. Abhi we'll see 25 to 50. If at all there is any number between 25 to 50, how do we solve the square? We have the first question, 42 ka square chahiye humko. So, 42 I understand it is between the range of 25 and 50. Correct? This is the point number 1 that is taken into consideration. Now, given that it is a 2-digit number, the square of it will be of 4 digits, correct? So, first thing I know is I have to have 4 blanks with it. Abhi I see the number is between 25 and 50. So, the first thing that I do is I take the last 2 digits. Now, last 2 digits 42 square if I have to do. So, the last 2 digits will be what? I'll do 50 minus 42. 50 minus 42 is what? 8, correct? 8 square will be the last 2 digits for 42 square. What I mean by saying is, I'll take 50 minus 42. The numbers are between 25 and 50. 50 I am taking as the base. 50 minus the number that is 42. I get 8. 8 ka square is 64. So, I understand the last 2 digits of 42 square will be nothing but 64. Now, coming to this part wherein the first 2 numbers are there. Now, I understand the numbers are between 25 and 50. Now, this number of 42 square will be 1600 se zyada, correct? 1600 means what? 40 ka square. 4 ka square is 16, easy to remember. So, 40 ka square would be 1600. 1600 se zyada. How much zyada will be that? 25 as the base I am taking minus 8. 8 is this number, 42. And 50 ka difference is 8. That difference of 8, I am subtracting it from my base of 25. 25 minus 8 gives me 17. So, here the 2 numbers, as I said, the number will be greater than 1600. How much greater? Slightly greater, correct? So, here 42 square is nothing but 1764. In my mind, I understood 40 ka square would be 1600. 1600 se zyada hona chahiye. So, zyada means when I do the calculation, 25 as my base minus this number of 8 gives me 17. And for this particular number, 50, since the number is between 25 and 50, 50 minus 42 gives me 8. 8 square is 64. So, I understand 1764 is the square for 42. See, 42 square is 1764. Here I have 42 square as 1764. Moving ahead. Now, if the square of the number from 51 to 75 needs to be found out. We will not do the multiplication of, let's say, 58 into 58. We will use the trick. Now, let us see an example. We have here 59 square. So, 59 square, again, I understand 60 square is what? 60 square is 3600, correct? 3600 se my number will be a little less. How much less? We'll see. Given that it is a 2-digit ka square, the answer has to be in 4 digits, correct? So, firstly, I understand I break my number into 4 different sections. So, here in this 4 numbers also, I break into the last 2 and the first 2. Now, the last 2 numbers, I understand it is 59 square. When I take the base of, for the last 2, I take 59 minus 50. Why? Because I understand 60 se thoda sa niche hai, correct? So, 59 minus 50, I understand the difference is 9. 9 ka square is 81. So here the two numbers will be 81. And here also I have 9. 9 ka square if I take on that way. Not necessary you will have it, in terms of the squares. 9 square is 81. So here you will have 81 only, not for that particular scenario. Means what? 51 se leke 60 if you see na, all the last digits. So if I take 52 square, 2 square if I take, last two digits will be 04. If I take 53 square, last three digits will be 09. 3 ka square is 9. So that way the numbers will be. But only for 51 to 60. Here my number is 59. The other way is 59 minus 50, that is 9. 9 square is 81. So I understand my two numbers here will be 81. Now coming to the first two numbers. The first two numbers I understand 50 se zyada hai. 50 se kitna zyada hai? I am taking my base as 50. Why? Because 60 se it is little less. 50 as my base. So 50 plus 9. Coming to the first two numbers, what we have is, now we need to know the 59 ka square. The last two are taken care. The first two will be, I am taking the base of 25 as the number. So 25 plus 9 if I do, given that I have to have little less than 60, little less than 3600, 25 plus 9, I understand it is 34. So here my first two numbers will be 34. So 59 square will be nothing but 3481. We'll quickly repeat. What we have is, we have 59 square. So it will be 4 numbers. I have divided into first two and the last two. Last two I understand 59 is my number. I subtract 50 as my base. I get 9. 9 square is 81. For the first two, what I do is, I take 5 as the base. Okay, 5 square is 25 plus the 9. The 9 that I have here. Okay, so 25 plus 9 gives me 34. So 3481 will be the answer for 59 square. So 59 square is 3481, which is less than 3600. So by that logic, I understood my answer is less than 3600 and 59 square is 3481 that I have calculated. Solving for the numbers of square between 76 and 100. Now let us take an example. We take 93 square. 93 square is little less than 100, correct? So firstly, my first thing is to break it into 4 parts. First number, second number, third number and fourth number. In this also I am breaking my number into the first two and the last two. The last two, what I do is, I take the base of 100 now. Why? Because 93 is closer to 100, correct? So 100 minus 93 gives me 7. 7 square will be 49. 49 will be the last two numbers that I have, correct? So my last two numbers are taken care, it is 49. What I have is, I have this number of 93. 93 minus 7 I do. What I get is 93 minus 7, which is 86. So my first two numbers here will be 86. Now why I have done this 93 minus 7? Because the number is less than 100, correct? Less than 100, a little less than 100. How much? It is 93. 93 and 100, the difference is 7. So 93 minus 7, it is 86. So here it will be 86. So all the squares between 76 and 100 can be found out by this approach. Firstly, from 100 we subtract the number. The difference that we get, we take the square. Then that will be the last two numbers. Then for the first two numbers, the number that is there, here we have 93, that we have taken, and the difference between 100 and that number. We have, see, 100 and 93, the difference is 7. We subtract 93 minus 7, we get 86, and 86 becomes the first two numbers of the square for my 93, or square for the number from 76 to 100. So my final answer for 93 square is nothing but 8649. So all the numbers between 76 and 100 can be calculated using this particular approach. So up till now we have seen, we have to remember the tables till 25. Then 25 to 50 we have seen one slot, how do we take the squares. Then 51 to 75 we have seen another slot, how do we take the squares for the numbers between that particular range. And this is the third range, 76 to 100. If we were to calculate the squares, how do we solve? So every number has a different approach. So numbers are divided from 100, broken down into 4 sections, 1 to 25 by heart, 25 to 50, then 51 to 75 and 76 to 100. So this is the concept of finding up the squares. Now moving ahead, square of any number with a unit place of 5. Till 100 we have seen how do we solve the squares. But now what if the unit place is 5? It becomes relatively easier if you have any number, let's say 45, 55, 65, 75, if you have to take the square of those numbers. Let us see with the help of an example. We have 65 square. Now 65 is a 2-digit number. The answer will have 4 numbers. So this is my first step. Now any number 45, 55, 65 which has unit place of 5, we understand that the last 2 numbers will be nothing but 5 square. So 5 square is nothing but 25. So my last 2 digits here will be 25. Any number you take 15, you take 25, 35, 45 and so on. The last number unit place be 5. So it will be last 2 numbers will be 25. Now coming to the first 2 numbers. Here I have 6. So 65 square, what it will be? It will be 6 into the next number of 6, that is 7. So 6 into 7 is 42. So 42 will come here. How do we see? The formula is n, that is any number. If it is 4, then it will be 4 into 5. It is 3, it will be 3 into 4. So the next number. So n into n plus 1 is the formula. For the unit place to be 5, if I have to calculate the square, the first 2 numbers can be calculated this way. So n into n plus 1 means 6 into 7. 6 into 7 gives me 42. Okay, so this is 6 into 7. So here it will be 42 and 25. So 4225 will be the square for 65. Okay, so 65 square we get as 4225. So this way any number which has a unit place of 5, what we do is the last 2 numbers will be the square of 5, that is 25, and the first 2 numbers will be whatever number we have before 5, that into the next number. So if it is 6, it will be 7, 6 into 7. If it is 5, it will be 5 into 6. If the number is 45, the number will be 4 into 5 for the first 2. Okay. So that way n into n plus 1 means the next number that will come here as the first 2 digits. So 65 square we get 4225. Now I hope finding the squares will be a no problem for you if the numbers are from 0 to 100, if the unit place is 5. Coming to the next concept in terms of having our calculations faster, it is conversion fraction to percentages. So there are various fractions, let's say 1 by 10, 2 by 10. Okay, 1 by 10 it becomes relatively easier, it is 10%. But what if the number is 1 by 7 or it is 1 by 8? So for that, having the conversion of a fraction into percentages becomes relatively important for your quicker calculations. So this will help in your DI, in your percentage, the problems which has fractions. So converting fractions into percentages becomes easier and vice versa. If it is in percentage, you have to convert it into fraction for easier solving. This is very helpful in your data interpretation. Let us see, there are some basic fractions that we need to remember. So this is the table. So we have from 1 by 2, that is half, till 1 by 20. Let us see each one. When we say 1 by 2, it is nothing but half. Half is nothing but 50% in terms of the percentage. When I say 1 by 3 means 1/3, it is 33%. 1/4 is 25%, 1 by 4. And 1 by 5 is 20%, 1 by 6 is 16.67%, 1 by 7 is 14.28%. Now, if it is 1 by 7 is 14.28%, if I say how much 2 by 7 would be? 2 by 7 would be nothing but this multiplied by 2, correct? Double of this. So that way, if it is, any number, let us say we have 1 by 8, it is 12.5. But what if I say I want to find out for 2 by 8? So only if you know 1 by 8, it is 12.5. 2 by 8 would be double. 2 by 8 is nothing but 1 by 4. Now 1 by 4, if we see here, it is nothing but 25%, and double of 12.5 is nothing but 25. So both ways we can find out, or we can see that we get the answer. Okay, so that way in simple terms, if you know one fraction, the other fractions or the percentage conversion becomes relatively easier. Okay, continuing further, 1 by 9 is 11.11%, 1 by 10 relatively easier, 10%. So 2 by 10 would be 20%, 3 by 10 would be 30%, so on and so forth. 1 by 11, 9.09%. So here one thing to remember, 1 by 9 if we see we have 11 table. But 1 by 11 if we see we have 9 tables. So that way you can remember. 1 by 12 it is 8.33%. 1 by 13 7.69%. 1 by 14 is 7.14%. 1 by 15 is 6.67%. 1 by 16 is 6.25%. Now if I say I want for 2 by 16. Now if I say I want to calculate for 2 by 16, 2 by 16 will be nothing but 1 by 8, correct? Now 1 by 8 I know it is 12.5, correct? 1 by 8, here it is 1 by 16, 1 by 16 is 6.25, 1 by 8 is 12.5. So that way I can remember the denominator is greater, so the value here is lesser, correct? See, 1 by 8 is 12.5%, 1 by 16 that is 6.25%, but 2 by 16 is nothing but 1 by 8 that is 12.5%. So that way you can connect, or you can break down all the fractions in order to come up to a percentage as well. Okay. Continuing further, 1 by 17 it is 5.88%, 1 by 18 is 5.55%, 1 by 19 is 5.26%, 1 by 20 is 5%, and 1 is 100%. So these are the basic fractions that you need to take into consideration while you are converting into percentages. And with this also there are various. So here, as I said, we have 1 by 8. So 2 by 8 would be how much? It will be 1 by 4. 1 by 4 again is 25%. So that way you can remember, you can recollect, it becomes easier for your understanding. Okay. Let us see how do we get from a particular fraction into a percentage. Let us see with the help of an example. So, example here I have 8 by 7 is what percentage? Here in the table, when we see 1 by 7%, the question is asking for 8 by 7%. But we are aware 1 by 7% is 14.28%. Let us see how do we solve. We will take this into consideration. 1 by 7 is 14.28%. Example, we have 8 by 7%. 8 by 7 as a fraction is how much in terms of the percentage? Let us see how do we solve. See, 8 by 7 is nothing but 8 alag se into 1 by 7. So, what we have done is 8 and 7 we have broken down. 8 alag se into 1 by 7. Now, further 1 by 7 I told we will take into consideration is 14.28. One way of doing is whatever numerator we have, we multiply it by the 1 by upon that number. Means if I have your 4 by 7. So, one thing is 4 into 1 by 7. Now, 1 by 7 I know is 14.28%. So, 4 into this will give me the answer for 4 by 7. This is one way. Okay. So, 8 into 14.28 will give me 114.24 as the answer. So, 8 by 7 as a fraction in terms of percentage is 114.24%. Means what? 100% plus 14% more. This is one way of calculating. There is another way as well to calculate. What it means is 8 by 7 into is x percent. So, what is that x percent? See, 8 by 7 is 7 plus 1%, correct? So, 7 by 7 if we break it down, 7 upon 7 is nothing but 1. 1 plus 1 by 7. Now, 1 by 7 we are already aware it is 14.28 in terms of the fraction conversion, correct? So, it will be 1 that is 100% if we want to convert it into fraction. So, 1 is 100% plus 1 by 7 is 14.28%. So, 8 by 7 is nothing but 114.28%. Here in terms of the percentage, it will be 114.28% in simple terms. Okay. So, both ways you get the answer, but I feel this is relatively easier in terms of remembering the percentages, and then given that it is 8, we just break it down to 7 by 7 and 1 by 7. So, 7 by 7 is nothing but 1. 1 is 100%. So, this becomes relatively easier. So, I hope the conversion of fraction to percentage is now relatively easier. With practice, you will get more used to it with respect to the speed as well. Okay. Now, let us talk about factorials. Now, what are factorials? We understand we have 1 factorial, 2 factorial, 3 factorial. So, the only thing is from 1 factorial to 10 factorial, remembering becomes relatively difficult, but then when you have the numbers, how it is done, how the value is derived, you should know the derivation of it. See, when we talk about 1 factorial, it is nothing but multiplication of 1, which is 1. 2 factorial is 2 into 1, which is 2. 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 4 into 3 into 2 into 1, which is 24. 5 factorial is 5 into 4 into 3 into 2 into 1, which is 120. 6 factorial, 6 into 5 into 4 into 3 into 2 into 1, which is 720. And 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1, which is 5040. 8 factorial in the same way is 40320. 9 factorial is 362880 and 10 factorial is 3628800. Now, in terms of remembering, I would suggest you remember at least till 7 factorial. These numbers are relatively easier to remember, correct? Even if we take it till 6 factorial, 6 factorial is 720. Remembering this is relatively easier. Only 7 factorial, which is 5040, you need to remember. Okay, so this is the derivation of how a factorial is derived into a value. Nothing it is done, it is just that the number we take into consideration, we bring it down till 1 in order to have the least number, and then we multiply all the numbers. Okay, so like for example, 3 factorial is 3 into 2 into 1, brought 3 till the multiplication of 1, and 3 into 2 is 6, 6 into 1 is 6. So 3 factorial becomes 6 that way. So factorials are an easy way to remember how to by heart. So this was about factorials. The next concept is the BODMAS rule. Since our school days we are aware algebra में सीखा है BODMAS क्या होता है, brackets of or order or the power, division, multiplication, addition and subtraction. So सबसे पहले whenever we have this becomes handy in your simplification questions. Okay. So firstly you have to solve the brackets and then the order, if you have it square, cubes or roots, you have to solve that, and as well as if you have the order or the power, and then you have to take division into consideration, then multiplication, then finally addition and subtraction. This you need to remember majorly for your simplification type of questions, BODMAS rule. Okay. Now let us understand what a digital sum is. See, the digital root or digital sum of a non-negative integer is the single digit value obtained by an iterative process or summing the digits. Summing the digits means what? There is a long number if we have. We break it down into one single digit by doing the sum method. So that is the reason it is known as the digital sum. All the digits we take individually, we do the summing up, that is adding up. See, on each iteration, using the result from the previous iteration to compute the digit sum. The process continues until a single digit number is reached. So if there is a long number, as I said, we will break it down. Okay, there is only one exception to it that we will see. Further, what we have is the digital root of a number is equal to the remainder when the number is divided by 9. So when we get 9, we don't take it into consideration, we take it as 0. See, if the remainder is 0 and the number is greater than 0, then the digital root is 9. If the number is 0, then the digital root of the number is 0. If we get 9 as the sum, we consider it as 0. This is one point, and there is a note also it as an exception. So this rule does not apply to the division concept. See, useful to solve simplification problems except divisions. So whenever we have divisions, we will not use digital sum, we will not be able to use it, but in other aspects we can use the concept of digital sum. Let us see with the help of an example of a digital sum. See, we have an example, we need to solve 1235 into 34 into 45 plus 36. Now if you remember, we have to use the BODMAS rule, that was bracket, we don't have bracket, we don't have any off here, we don't have any order. Then division we don't have, then multiplication and then addition. So I understand here I have a multiplication, so I need to multiply the number first and then go for addition, correct? So my first step would be, in terms of the solution, by calculation what do we get? 1235 plus 34 into 45. The first thing that I will do is multiply these two numbers. 34 into 45 is nothing but 1530 plus 36 if I do. So here I have 1235 plus 1530 plus 36. So this is equivalent to 2801, means the question mark is equivalent to 2801. This is one way of calculating, we get the answer as by the traditional method. Now with the help of a digital sum, if I were to calculate what is the digital sum of this whole question, how do we solve? Let us see. Now with the traditional method of solving, first using the BODMAS rule, we have received the answer as 2801. Let us see, by digital sum, what do we have here? The number of 1235. Firstly, we break it down. How we are doing? Breaking the number into digits and then summing up. That is the reason it is known as digital sum, correct? So, 1 plus 2 plus 3 plus 5. Now, 5 and 5 gives me 10. 10 plus 1 gives me 11. Now, 11 here I have written it down. Okay? Further, I have 34 into 45. So, 34 is 3 plus 4. I have broken down, and 45 is 4 plus 5. I have broken it down. And this is plus 36. So 36 is 3 plus 6. All the digits I have broken down and then I will do the summing up. See here, if at all I have 2-digit number, even that I have to break it down to get it to 1 digit. 1 plus 1 will give me 2. Here 3 plus 4 gives me 7. 7 into. Now here I am not changing any multiplication or addition sign, or if at all there is any subtraction sign, I will not change the sign. What I will do is only take the digits and do the summing up. Okay? So 4 plus 5 we get as 9. 9, I told you, whenever we have 9 we consider it as 0. Whenever we get 0 we consider it as 0. Okay? So 5 plus 4 is 9. So here I have 7. 7 into 0. 3 plus 6 is also 9. Correct? So here also I get 0. So 7 into 0, I understand anything multiplied by 0 will give me 0. 0 plus 0, anything to adding to 0 plus 0 will be 0. So here I have this equation as 0. I have only 11 here. 11, we have to break it down into single digit, summing up the digits. So 11 is 1 plus 1. 1 plus 1 gives me 2 as the answer. Why? Because here everything is 0. So digital sum, my answer is 2. Now, the traditional method I had received the answer as 2801, correct? So 2 plus 8 gives me 10. 10 plus 1 gives me 11. 11 is 1 plus 1, which is 2. My digital answer sum is also matching. My traditional method answer is also matching. So digital sum of the question is equal to the digital sum of the answer. So this is equal to this, and digital sum is also 2, and the traditional method also answer comes to 2 by the way of digital sum. So this is the concept of using the digital sum. Let us see another example of the same concept of digital sum. What it says is, see, we have to solve 47 square plus 35% of 2560 minus 87 square. We will take only the digital sum now. Here we have square. So using the BODMAS rule, first we will do the power, then we will do percentages simultaneously, then addition and then subtraction. Okay? So first we have is 47 square. 47 is 4 plus 7. 4 plus 7 is 11. 11 is 1 plus 1. Correct? So I'll write it straightforwardly. 4 plus 7. 4 plus 7 is 11. 11 is 1 plus 1. 1 plus 1 is 2. 2 ka square we have to take. 2 ka square is 4. So 47 square is broken down into 4. Okay? Further we have 35% of 2560. So one more thing, whenever we have divided by 100, we don't take that into consideration. So what it will be, here we have 35 by 100 into 2560. 3 plus 5, it is 8. So here what I do is I write 8 here into 2560. Digital sum would be 6 plus 5 is 11. 11 plus 2 is 13. So 2 plus 5 plus 6 plus 0. 6 plus 5, 11. 11 plus 2, 13. So 13 is 1 plus 3. 1 plus 3 is 4. So here it will be 8 into 4. Correct? Talking about this number of minus 87 square. As I told, we are not changing any signs. Okay, whether we have multiplication, addition or division, we will keep that as it is. Now we have minus. So here we will do minus. We will bring it here. 87 is 8 plus 7. 8 plus 7 is 15. 15 is 1 plus 5. 1 plus 5 is 6. We have to take the square. 6 square is 36. 36 is 3 plus 6. 3 plus 6 is 9. 3 plus 6, this will become 0. Correct? Now here, 4 plus 8 4s is 32. 32 is 3 plus 2. 3 plus 2 is 5. And here minus 0. 4 plus 5 gives me 9. 9 is nothing but 0. So my answer for digital sum will be 0. Now if you take the traditional method and calculate this answer, the answer that you get, if you take that digital sum, that will be equivalent to 0. Okay? So this is by using digital sum, we understand the digital sum of this is equal to 0. So the digital sum will be 0. Now let us take another example. What do we have is, we have to solve this 27% of 450. minus x% of 375 is equal to 76.5. Now what we will do is we will solve this sum using the traditional method and then you see if the digital sum is the same or no. Okay, the digital sum, the answer is same or no. We will calculate. This we will use using the traditional method. So how do we solve? We have here 27% means what? 27 upon 100 if we do of 450 minus, let us say question mark percentage is there. So we will say x%. So x upon 100 of 375 is equal to 76.5 is there. If I want to remove the point, it will be 765 divided by 10, correct? Now, if I were to solve using the traditional method, the lengthy method, what I will do is, I will take all the numbers, I will try to reduce it and then go for finding out the value for x. How do we do that? See here, 0 and 0, I will cancel it out. So, this is 5 2s and this is 5 9s. Okay. Now, this 100 and 375 by the table of 25. 25 4s is 100 and 25 1s is 25. I am left with is 12, 125. So, 25 15s is 375. So, here I have the cancellation and this can also be divided by 5. So, here I will have 2 and here I will have 1, 5 and 3. 153 by 2. Okay. So, now I have 27 into 9 by 2 minus x by 4, that is 15x by 4 is equal to 153 divided by 2. So, here I have 2, here I have 4. So, if I multiply this also with 4, what I will get is the denominator will be 4 for both, correct? So, what I do is I multiply this portion by 2. So, what I will have is 2 into 27. 2 into 57 gives me 54 into, I will take it 9 as it is, 54 into 9, here I have minus 15x and the common denominator would be 4 is equal to 153 divided by 2. So, this and this I can cancel, 2 1s and 2 2s, correct? Now, here if I see 54, 9 and 15, 3 is common, by the table of 3 all can be cancelled out. So, what I do is I take 3 common, here it will be 54 into 3, what I have done is 54 into 9, from here 9 I have taken 3 common. So, here it will be 3 into 3, correct? Minus 5x is equal to 153, this is it divided by 2. Why? Because 2 here is cancelled, here only 2 is remaining. Now, 3 and 153 can be cancelled by the table of 3. 3 1s and 3 51s, correct? So, now what I have is 54 into 3 minus 5x divided by 2 is equal to 51. This 2 I will take it to the other side, it will become multiply, here it is divide, it will be multiply. So, I have is 54 into 3 minus 5x is equal to 102, correct? 51 into 2. Now, 54 into 3 is 162 minus 5x is equal to 102. 102 I bring it to the other side, 5x I bring it to that side. So, 162 minus 102 will give me 60 is equal to 5x, correct? X, the value will be 12. X is nothing but the percentage value, percentage, correct? X percentage means here percentage will be 12%. So, x is equal to 12. Now, we have received the value of x as 12. Now, finding out the answer 76.5 using the digital sum, do check out what you are getting. So, the value of your answer will be equal to the digital sum of your question. So, question and answer will have the same digital sum. So, this is the concept of digital sum. So, we get the answer x as equal to 12. So, subscribe for more videos and stay tuned with Top Scholars. Thank you.